Hello and good morning to Dr. Inawati. My name is Muhammad Zaidi bin Abbas with matrix number 82706. Today we will present about industrial effluent treatment system that we study at the Bau Palm Oil Mill. This is my group member I work with. First is Darren Gimbang. Second, me myself, Muhammad Zaidi, Kebrisaka, Harrington, and Muhammad Zaid Ifwat. In this project, the Bau palm oil mill has been chosen by us for us to study about their wastewater treatment plant. The Bau palm oil mill is the industry that needs a great wastewater treatment plant to treat the effluent from their factory. The location of this industry is at Bau, Sarawak and surrounded by the forest or palm oil trees. The nearest river and the river to flow the treated wastewater is Sungai Tong or Kayan. This industry already has their existing wastewater treatment plant that uses a hybrid treatment plant or more one-waste stabilization pond (WSP). Because of this plan, this factory has received many awards in wastewater treatment plant such as Anugerah Kilang Kelapa Sawit Lestari 2033. However, the existing wastewater treatment plant got a problem when heavy rain season because the existing wastewater treatment plant is only limit for flow that 1000 meter cube per day. Then, to improve this, we propose the improvement in the wastewater treatment plant for Bau palm oil mill.
Hello and good morning. Today I'm going to present about the existing wastewater treatment at Bau Palm Oil Mill, Bapom. Currently, Bapom uses a hybrid biological treatment system with a daily capacity of 1000 cubic meter. The treated effluent from the Bau Palm Oil Mill will be discharged to Sungai Tong. This treated effluent need to comply with the standard A of EQA 1974. There are four types of treatment unit which are preliminary treatment, primary treatment, secondary treatment, and tertiary treatment. This is the existing wastewater treatment plant of Bapom flowchart. The process begins with preliminary treatment where the raw effluent passes through a slush pit to settle heavy solids and then moves into a cooling pond to reduce its temperature, followed by the screening to remove debris. For the primary treatment involves a single anaerobic digester where the microbes break down organic pollutants in the absence of oxygen and a sedimentation tank that will help to recycle the slush. For secondary treatment, it consists of four facultative ponds, two aerobic ponds, and an algae pond. These units will help in reducing the BOD, COD, suspended solids, and nutrients like nitrogen and phosphorus of the effluent. For the tertiary treatment, it is including the aerobic reactors, clarifier, and both stone and sand filters. The system also have contact aeration reactors or CAR units which boost oxygen levels and enhance microbial breakdown of remaining pollutants. Although the wastewater treatment system at Bau Palm Oil Mill has been effective, it faces several key limitations. Firstly, the system is designed to treat only 1000 cubic meters of effluent per day. During heavy rainfall, this capacity is often exceeded, which causes the overflow and risking untreated discharge into the Sungai Tong. Secondly, the number of contact aeration reactors is limited to just 4 units. This makes it difficult to handle higher pollutant loads, especially during peak operation or rainy season. Thirdly, there is no odor control system in place. Gases like methane and hydrogen sulfide are released from the anaerobic digester, affecting the air quality and potentially causing discomfort to nearby communities. In addition, the mill lacks a proper sludge treatment facility. The sludge is only stored and not stabilized or treated, which can lead to leach issues and environmental risks. Lastly, the methane gas produced during digestion is flared off, resulting in wasted energy and greenhouse gas emission.
Now that we have identified the limitation of the existing wastewater treatment system, our proposal aims to improve it by upgrading, not replacing the existing setup. The goal is to keep the parts that still work well and enhance the system to meet today's needs more effectively. Starting with the primary treatment stage, the current anaerobic pond is both uncovered and undersized, making it prone to overflow during heavy rainfall and releasing unpleasant odors such as methane and hydrogen sulfide. To resolve this, we propose adding additional anaerobic ponds to increase treatment capacity, as well as installing gas canvas covers. These covers helps to trap those harmful gases and prevent rainwater dilution and allow for the capture of methane, which can be flared or used as an energy resource. In the tertiary treatment stage, the plant currently uses four contact aeration reactor or CAR, one clarifier and sand filters. However, the system often struggles during high flow periods, leading to poor final treatment of the water. To solve this, we suggest by increasing the number of CAR units from 4 to 6 or even 9 units to handle larger volumes more effectively. We also propose upgrading the clarifier for better sludge removal and adding ultrafiltration membrane to help filter out fine particles, colors, and leftover pollutants. These changes will help ensure the treated water consistently meet the high quality standard A discharge requirements.
Hello, my name is Muhammad Zainifat and I'll be talking about the tertiary treatment tank design. So the problem in Bapom is that whenever it rains, the tank would overflow. The that would overflow is the contact aeration reactor. So what we propose is they can add another 6 tanks, but this time the current tank and the new tank will be in parallel configuration. What parallel configuration does is it will divide the peak flow by 2. That means it will be able to sustain the peak flow whenever it rains. So for the tank dimension, it will be the same as the previous tank or the current tank design, which is 0.2 meters freeboard, 7.8 meters of depth, width of 8 meters, and breadth of 4 meters. That's all from me. Thank you. Evaluation of impacts. One of them is water quality because we are concerned about the discharge of the palm oil mill. And we can also measure such as BOD, COD, DO, TSS, nutrients, oil and grease being released to the river. Why? Because poor treatment can harm the local river and the locals. But it is found that the discharge is in compliance with Standard A EQA 1974, which means it is good for recreational activities and is not harmful to the river's ecosystem or to the people. Air quality. So all palm mill will emit methane, carbon dioxide, hydrogen sulfide, and odorous gas. Poor management of this emission will trigger complaints by the communities. And these gases can harmfully affect respiratory health, especially for workers and nearby residents. But for now, we have not heard any of these complaints. So it means they are very compliant with the Jabatan Alam Sekitar guidelines.
Next, we want to evaluate the impacts of BAPOM to the soil and land use. BAPOM covers large areas of land used for palm oil mill influence, which such as treatment ponds, sludge storage, and also waste handling. And possible can happen is soil erosion, contamination, and loss of land productivity. If the management of the effluent is very poor and unprofessional conduct. So this soil erosion, contamination, and loss of land productivity can caused by extensive of work, leach of heavy metals and nutrients, and also possible happen spills of fuel, lubricants, and also chemical use during the operation in this mill. And Don't forget also the location of Bapom, which surround by the agriculture's areas, can impact the plantation productivity and surrounding ecosystem. After evaluation of impacts, it is necessary for us to do mitigation measures also. So mitigation measures is essential to minimize the adverse impact of the wastewater treatment plant on the environment and human health. This method focus on controlling and minimizing the harmful effects of palm oil meal influence. So the first one, water quality. The mitigation measures that we can do in water quality is ensuring all discharge influence caters to standard of EQA 1974. So what can we do to mitigate the water quality? The first one we can do apply membrane separation technologies such as ultrafiltration or reverse osmosis, and the second one we can do low energy can imply low energy tertiary treatment option such as constructing with lead with lens, and we also can regular effluent monitoring, including routine sampling to check the water quality like BOD, COD, and TTS, and so on. Mitigation measures for air quality can be addressed through both preventive and control strategies. For control strategies, we can install cyclone separators, wet scrubbers, and electrostatic precipitators. So this installment of control technology can reduce the emission of burning fuel from the biomass boiler. And we can do a preventive solution, which is relate to the anaerobic treatment. We know that anaerobic treatment produce gas such as methane, hydrogen sulfide, and also volatile organic compounds. So this gas is really dangerous. What we can do here is to use closed anaerobic digester instead of using open ponds. We should use closed anaerobic digester because this closed anaerobic digester it can capture the biogas and then convert them to a renewable energy for the meal. Mitigation measures for soil and land use. Soil contamination and land degradation at Bapom can be reduced through proper site planning, containment infrastructure, and restoration strategies. First, all chemicals and fuel storage should be placed in burden zones, and planting native vegetation to restore soil stability. And in case if Bapom or any industry want to extend their wastewater treatment plant, they can use temporary drains and sediment traps to avoid runoff during flood, and also it can affect the quality of the soil as well. And the last one, the industry can reuse sludge as a biofertilizers or dispose them at the approved deposit sites by the Department of Environment. Thus, the importance of mitigation measures of the soil and land use is to prevent soil pollution and restore the soil stability, as I mentioned just now, and ensuring that no runoff into the waterways and the farmland. In conclusion, the site visit for IETS has enlightened the student with a lot more information about each treatment unit and its detailed operating system, which involve handling the waste of oil palm produced by Papom. Industry should imply sustainable industry practice through idea and adjustment for the better treatment system. It is crucial for the future engineer not only to consider the profit of industry but to enhance the knowledge of any waste water treatment and design them effectively to treat influent in compliance with regulatory standards, ensuring environmental protection and sustainable operation of the facility.